Gaffney, and this is Physics 2211 Lab number 5. Okay, so the purpose of my lab that I chose today is to compare the motion of a ball thrown on the Earth versus on the Moon, to see which one would be thrown further. Not a huge surprise to many people here, it was further on the Moon. And the physical principle that I used today was the kinematic equation, which is, in this case, the position update equation. Okay, so for the setup of this experiment, I recorded myself lightly tossing a ball outside to observe its motion in 2 dimensions. I tracked that data on the tracker app to get the initial velocity. I created a simple model on the glow script that will tell me what the final distance is for the ball thrown on the moon, and then I compare the two values together. Okay, so what are the initial conditions? So I found that the initial position is 0.50 meters. The velocity is 1.498, 1.1080 meters per second. The mass of the ball is 0.15 kilograms, and the value of g on the moon is 1.62 meters per second squared. And then the system in this experiment is the ball and the Earth slash the moon, and the surroundings is everything else. So here's the physical experiment. You can see I filmed it outside my dorm building. Shout out Smith. So basically, you can see the arch there. It's not a very hard throw. I kind of just tossed it up in the air a little bit just to get the nice arching pattern. And you can see kind of all the data right there from the tracking. And really, what I was mostly concerned with here is the initial velocity, which I just showed in the last slide, and then the final distance and the axis traveled, which is 1.105 meters. And then as far as the glow script code, it wasn't like super complicated. I just kind of set up something that would output the final x position of the ball on the moon, and I didn't really do like an actual model because I don't really know how to code that. But this is kind of what I made, and so you can see I kind of set up all the initial everything initial right there, and then I did the calculations and printed it out, and I found that on the moon, if I had thrown it with the exact same initial velocity, the distance traveled would be 1.723 meters in the exit direction. So the comparison between these two is that the ball would travel 0.618 meters further in the x direction when thrown on the moon at the exact same initial velocity as compared to being thrown on the Earth. And then some possible sources of error could have been I did not measure the starting height correctly, and there was too much drag on the ball in the experiment since I filmed this outside and it was a little bit windy. So why does the ball travel further on the moon? Since the gravitational pull of the moon is much lower than that of the Earth, it takes longer for the gravitational force to slow down the vertical component of the ball's velocity, causing it to hit the floor. This means that there is more time in the air for the ball to travel in a horizontal distance than there is on Earth. And then what if this experiment was repeated on Jupiter? Since Jupiter has a much stronger gravitational pull than that of Earth, the ball would travel a much shorter distance than it would on Earth, due to it having a much less hang time in the air. Thank you. That's all I have for you today.